All right, so we are finally in Unit 10. We are in statistics. Yay! The Algebra 2 year is almost over. There's a light at the end of the tunnel. So the last thing we talk about, whether it's in Algebra 1 or Algebra 2, is always statistics. And statistics is talking about data. We have a bunch of data given to us on a daily basis, and we need to really understand it. We can't just take it at face value. There's a lot of tools we have to say, well, let me look at those numbers using all these tools. That's what we're talking about. Today, the first tool we have to understand is variability. Simply, when we collect data, there's going to be variability in it. In other words, it's not always going to be the same number. Why is that? We have a whole bunch of different tools that will explain why we have variability. All right, so right now we're going to talk about 4 types of variability. It may help you to just, right now, go forward to this timestamp, take a screenshot of the page, print it out, and then cut it out and put it in your notebook. There's going to be a lot of writing, so it may be easier for you to just kind of read along and take side notes than to write everything down. Okay, let's talk about how our data can vary. So for instance, we may collect information by observing it or measuring it. So what happens if we observe or measure something? It's a variability that is introduced due to either our measuring instruments not being precise enough or differences into how 2 people read the measurement. So what does that mean? So let's talk about the measuring variability. Our measuring instruments not being precise enough? How about with a ruler? Some of our rulers are so old and chipped that if we were to say measure how long, let's say we were measuring people's feet, maybe we won't all measure it to the same 1/4 of an inch or 1/8 of an inch. Or how about this one? Say we were timing kids sprinting. We as coaches always do this. We could get 2 different times due to how each person starts or stops the stopwatch. One could start it just a hair after the other, or stop it, or see things differently. So for us, when we do this with field hockey at Riverhead, we always have 2 coaches timing at the end, and then we take the average of our 2 times. Natural variability. Variability that accounts for the fact that members of populations are simply different. So what does that mean? Well, we're human. We're all different. Take athletes. We all go to practice. And some kids are just better athletically inclined than others. Famous, again, going back to coaching, there's a famous phrase that some of you who are athletes may hear. You can't teach quickness. You're either fast or you're not. You can get better skills, but as hard as I try, I'm just not going to run as fast as other people. They're just faster than me. Induced variability. This type of variability is in marked contrast to natural. It occurs because we have assigned our population or sample 2 or more treatment groups and then observe the variability between the groups. What? What does that mean? Basically, these are control groups. We forced one group to be different than the other because we did a placebo, like a sugar pill. We're going to talk more about that in our final example for the day. So we induced that one group will end up being different than the other because maybe we gave one group a drug that would be effective and the other group we didn't. And the last one, sample variability. This is a type of variability that occurs when we take multiple samples from a population randomly. These samples will be different due to the randomness of the sampling process. Once again, what does that mean? It means this. We have a huge population, and we just take a sample. So in other words, I'm going to have a population down here, right? I'm just doing a whole bunch of different dots. Okay, there we go. And say we wanted to take a sample. That means we don't want to count all these pink, yellow, and green dots. We just want to count a few. Let's say I look just at that sample right there. So we have a variability there. We have some green, we have some yellow, and we have some pink. So later on, we do a different sample. But look, say we take this sample over here. There's no green in there whatsoever. We're going to get different results. So that's going to be what's going to happen in about 5 or 6 lessons. We're going to learn that if we study a huge population, something that there's no way we could ever study every single individual, but what we can study is little parts of that population multiple times, then we will get a really clear picture of the big population. All right, so let's look at some examples. Example 1. We want to make sure that when we do a study, we have a good randomization. We want to try and eliminate as much variability as we talked about. The 3 major types of way to collect data are described below. We want to eliminate bias. All right. So for example, next year when you're in IB, you're going to have to do an IB assessment, an IA, I believe they call it. And if you go on to Ms. Shahovska's IB math studies, they have you do a statistical study. So some of you may say, we're going to put out a survey. We're going to collect data from the population where the variability is not induced by treatments, but by the sample itself. What does that mean? So in other words, let's say you wanted to survey the nation's favorite baseball team. You're not going to stand in front of Yankee Stadium and ask people leaving the ballpark who their favorite team is, because they're all going to say the Shankies, when we all know the favorite team is... Okay. Observational studies. Sometimes we're going to collect data by just observing. So we collect data from a population where assignment of individuals from the population into treatment groups is not under the control of those performing the study. What does that mean? It means this. Say we want to see if people with higher income have better health. You're putting them into groups. But I can't affect people who have an higher income. I can't say, oh, look, here's $50,000 I'm not using. Let's see how your health fares now. I have no control over who makes that money. I can only observe. I can only go to people, observe, wow, you're really wealthy. Let me see what your health is like. And the last one, experimental study. This is the one that we were talking about, that control group. So here's what I said. So in an experimental study, we are going to randomly assign people into treatment groups to determine how one thing affects one group and not the other. So we're using a control group, assigning people to groups. However, we need to come some way to randomly assign them. We can't play favors. So take, for example, Grey's Anatomy, Season 7, Episode 19. Oh, Sophia, you're just excited right now. Remember Meredith switched the paperwork for Derek's Alzheimer's trials to ensure that Adele Weber got the treatment? We totally understand her motivation. Adele seems to be deteriorating quickly, but the chief is a friend. We're pretty sure that tampering with clinical trials is highly unethical. And we found out later that Meredith did get in a lot of trouble, and Derek's trial had to go by the wayside because mathematically it was not random. She put her fingers in the pie, and she messed up the random assignment. All right. So how do we pick randomness? You guys can't really say, oh, we'll randomly pick people because there's some bias in there. You can't even say you're going to randomly pick numbers because there's some bias. For me, I like groups of 5. I've told you that. So when I tend to pick numbers, there would be like 25, 15, 5. I don't know why. I just like groups of 5. So let's say we had 10 people here. Here's their height. And we randomly wanted to select 5 people. How can we do this to ensure pure randomness? Well, there's actually things out there called random number tables. And I got one right here for you. Here it is. It's just a bunch of random numbers. And if you notice, they're 10,000. Well, we can use this a whole bunch of different ways. Here's one way we could do it. We could say that we are going to look at the last digit in a column. So when I come back to that table, I'm going to pick a column. Let's pick column E. And the last digit in column E is a 1. So I'll come over here and I will say, okay, I'm going to pick the first person. All right, let's go look at our table again. And then it's a 2, the last digit. So I'm going to pick person number 2. And then I'm going to come here and guess what? The last digit here is a 2 again. So I'm not going to pick 2 again. 4. Get the idea? And then the next one, we can grab the last 2. The next one was an 8. Oh, we can't pick 1. We already picked 4. 8 and 5. There we go. So if I were picking 5 random people, there it is. Run 2 samples. Show the answers are different, and this is an example of sample variability. So if I sampled these kids, and I said there's 70, 68, 75, 65, and 62 in height. So now I'm going to go back to my random number. I'm going to pick the first digit, but I'm going to go in a row. All right, so I'm going to pick the first digit of this row right here. So that means I'm picking 7, 2, 1, and 6. 7, 2, 1, 6, and I need one more. And 9. All right, so if I picked it the second time, it would be 70, 68, 69, 58, and 66. And you can see that these will not give me the same numbers. So I have a sample variability. One sample will be different than the other sample. Bye-bye.